On this Silverado diesel, P2452 points us toward the diesel particulate filter differential pressure sensor circuit. In plain language, the ECM is seeing a pressure sensor signal that may not make sense for the operating state. The truck may show an emissions or exhaust fluid message, after-treatment operation may be affected, or the code may store with little obvious drivability complaint. Keep the broad fault areas in mind: the sensor, the signal circuit, the reference voltage feed, the low reference, connector or harness issues, and the control module only after the circuit checks support it. Start with the basic system checks, follow a structured diagnostic approach, and make sure you understand the diagnostic category before you start probing circuits. The differential pressure sensor measures pressure difference across the particulate filter. As filter restriction and pressure increase, the sensor signal voltage increases. The ECM supplies the regulated reference voltage feed, the signal circuit is an ECM input, and the low reference is grounded through the ECM. The typical scan data gives you some direction. The 5-volt reference row is shown as 0 kPa, 0 psi, 0 kPa, 0 psi, 0 kPa, 0 psi. A signal open or short to voltage pattern is shown as 0 kPa, 0 psi, 100 kPa, 14.5 psi, and 100 kPa, 14.5 psi. A low reference open is shown as 100 kPa, 14.5 psi. For P2452, the monitor is looking for the sensor value to be outside its calibrated range from greater than 3 seconds. Treat the running conditions as monitor gates. One of those gates is ignition off for greater than 10 seconds before the ignition on check. If other codes are present, especially a reference voltage code such as P0641, handle that first because it can affect this sensor circuit. With the ignition on and the vehicle in service mode, first confirm P0641 is not set. If it is set, do not keep going down this sensor path yet. If it is not set, look at the scan tool particulate filter differential pressure value. At idle and normal operating temperature, the expected range is 0 to 10 kPa, 0 to 1.5 psi. If the value is outside 0 to 10 kPa, 0 to 1.5 psi, move into circuit testing. If the value is in range, watch it for dropouts or spikes. Wiggle the B154 sensor harness and connector. Then wiggle the X3 connector area at the K20 engine control module. If the value spikes or drops out during those checks, repair the affected wiring, terminals, or connector condition. If it stays stable, reproduce the operating conditions or the captured failure conditions and confirm whether P2452 sets again. If it does not reset, the system is okay at that time. If it resets, continue into circuit testing. Before checking ground or low reference continuity, power the vehicle down fully. It may take up to 2 minutes for all vehicle systems to power down enough for an accurate continuity test. With the ignition and all systems off, disconnect the B154 differential pressure sensor connector. Test between low reference terminal 2 and ground. You want less than 10 ohms. If that test is 10 ohms or greater, disconnect the K20 engine control module connector and check the low reference circuit from terminal 2 at the component harness to terminal 76 at X3 on the control module harness. That circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the diagnostic path supports replacing the K20 engine control module. If the original low reference to ground test was less than 10 ohms, turn the ignition on in service mode and check the 5-volt reference between terminal 3 and low reference terminal 2. The expected voltage is 4.8 to 5.2 volts. If it is less than 4.8 volts, turn the ignition off, disconnect X3 at the K20, and test the 5-volt reference circuit at terminal 3 to ground for infinite resistance. Anything less than infinite resistance means repair the short to ground. If it is infinite, check terminal 3 at the component harness to terminal 78 at X3 on the control module harness for less than 2 ohms. If that is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the path supports replacing the K20 engine control module. If the 5-volt reference is greater than 5.2 volts, turn the ignition off. Disconnect X3 at the K20, turn the ignition back on in service mode, and check terminal 3 to ground. It should be less than 1 volt. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, the path supports replacing the K20 engine control module. If the 5-volt reference is between 4.8 and 5.2 volts, move to the signal side. With the sensor disconnected, the scan tool particulate filter differential pressure sensor parameter should be greater than 4.8 volts. If it is 4.8 volts or less, turn the ignition off, disconnect X3 at the K20, and test signal terminal 1 at the component harness to ground for infinite resistance. If it is less than infinite resistance, repair the short to ground. If it is infinite, the path supports replacing the K20 engine control module. If the scan tool parameter is greater than 4.8 volts, connect a 3A fuse jumper wire between signal terminal 1 and low reference terminal 2. The scan tool parameter should drop to less than 0.5 volts. If it stays at 0.5 volts or greater, turn the ignition off, remove the jumper, disconnect X3 at the K20, turn the ignition on in service mode, and test signal terminal 1 to ground. It should be less than 1 volt. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, turn the ignition off and check signal terminal 1 at the component harness to terminal 77 at X3 on the control module harness for less than 2 ohms. If that circuit is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the path supports replacing the K20 engine control module. If the jumper test pulls the parameter below 0.5 volts, test or replace the B154 diesel particulate filter exhaust differential pressure sensor. After the repair, verify the repair and confirm P2452 stays gone under the same kind of conditions that originally set it. Keep verification separate from circuit testing. The point now is to prove the fix, not keep diagnosing. If the driver information message says service emission system or service exhaust fluid system, run the reducted system tamper service bay test. That clears the applicable message when used under that condition. The takeaway: diagnose P2452 as a sensor circuit first. Prove the low reference, prove the 5-volt reference, then prove the signal circuit before condemning the sensor or module. For more diagnostic training, visit stepdiagnostics.com.